This video shows how to use the free pro version of UltiMaker Digital Factory to prepare a file for 3D printing. Specifically, we focus on using a MakerBot Sketch Large printer at the Gerstein MADLab 3D printing services at U of T libraries. This is the home page of UltiMaker Digital Factory. First, you need to make an account. It is free to use, and you can use your U of T email to sign up. Once you've created your account, you can sign in just as I'm doing right now. From this page, you can click on Prepare, and this will open up a blank workspace. At the top of your workspace, you will see a folder icon. This allows you to upload your STL file. For this example, I have an STL file of the Pokemon Squirtle that I'm hoping to print. So I'll select Import and Upload, and then the file I want to work with. Now that my file is uploaded into the space, let me draw your attention to the three main sections of this workspace that will be useful. Firstly, there's the top menu. In the top menu, you'll find an option for clearing the build plate, as well as a drop-down menu. In the drop-down menu, you'll find common actions like undo, copy, and paste, as well as your keyboard shortcuts work for those actions. In the left menu, you'll find different options for moving and manipulating your object. In the right menu is where you'll find different options for specifying the printer settings. Now let's dive more in depth on the left menu. If I select the first option, you'll see that the workspace uses a coordinate system. You can specify the amount of units you want to move an object in a specific direction. To center your objects, you can set the values to 0. You can also manually move the model by selecting and dragging the red, green, and blue arrows. These arrows correspond to the X, Y, and Z axes. If I deselect drop-down model, that allows the model to float above the build plate. For most printing jobs, you'll want to enable drop-down model. The next option in the left menu is Scale. This changes the size of the object. You can see the actual size of your object in millimeters, and you can edit these values to a specific size. As well, you can specify a scaling percentage. Uniform scaling is toggled on by default, but if you deselect this, then you can change a specific dimension, for instance, the height. Next, we have Rotate. This lets you turn the object based on degree values in the X, Y, and Z axes. This can also be done by selecting the model and dragging the corresponding colored curved line. Lastly, you can select Multiply and create multiple copies of your object. Grid placement is toggled on so that copies are uniformly placed on the build plate. You can undo any transformations you've done up to this point by pressing Reset up in the top left. After you're done editing the size and location of your object, you can move on to changing the 3D printing settings. At the top, you can see the options of Prepare or Preview. First, we prepare the object to our specifications, then we will flip over to Preview when we're ready to slice. Within Prepare, firstly and most importantly, select the correct printer under Printer Configuration. This tells the slicing software the dimensions of the specific printer you are using. Within our lab, we use MakerBot Sketch Large. Expand Settings and you will see different specifications. These settings can change to decrease print time, make prints stronger, and set up supports to help ensure the success of your print. Generally, the default settings will work for most prints. However, I'll go over some important settings. First, the resolution. This is the height of the layers in the printed object. The lower the height, the smoother and less visible the layers. In the free pro version of Digital Factory, the layer height or resolution is fixed to 0.2 millimeters, which means that each layer is 0.2 millimeters thick. Next is the infill density. This changes how much support material is used inside of the object. The infill is needed to provide structure and support, but is not visible in the final product. Lowering the value makes the object less dense, which means it will be lighter, use less material, and have a faster print time. But as a trade-off, the object may be less durable. For instance, I'll change it to be lower, 15%. Next, there's shell thickness. This specifies the thickness of the outer layer of the object. The first box changes the thickness of the sides, and the second box changes the thickness of the top and bottom. Next, there's infill pattern. This relates to the structural integrity of the inside of your object. By default, it is set to zigzag. Changing the setting can be useful for objects that have specific infill needs due to its shape or size. Next are supports. Supports are off by default, but if your object has any overhanging or floating elements, like the Squirtle example, you'll need to toggle this on. Under Type, there's options for style of support. There's Normal and Tree. Normal is more reliable in our experience, though it does use more material, and Tree can be a bit easier to remove in general. For this example, I'll choose Normal. Next, there's Placement. The options are touching the build plate or everywhere. Touching the build plate is useful for easier support removal and cleaner surfaces, but everywhere provides better stability for complex models. I'll choose everywhere. Lastly, there's adhesion. This adds additional filament material to the base of your print that allows the print to better adhere to the build plate. The options are skirt, brim, raft, or none, and these provide varying degrees of adhesion, with rafts being the best for adhesion and stability of the print. In the Gerstein lab, we ask that you use rafts to protect the build plate and the printer during object removal. Lastly, check if your print will have any issues printing. Warnings and errors are flagged under Print Validation. Commonly, it will warn you that your object has overhanging elements that need supports. If you click the error notice, it will take you to a setting or support page that will help you resolve the issue. Once all settings have been finalized and no issues are flagged, click the blue Slice button. Now we have flipped from Prepare to Preview. From this screen, you can see the estimated print time, which is what you use to determine your booking time. This is just an estimate. Always assume it will go a few minutes longer. As well, you need to account for the printer heating up and cooling down, so plan accordingly. Now we can download our project. This will create a .makerbot file, which is readable by the MakerBot printers. Save your downloaded .makerbot file onto a USB and bring it to the lab. Then you're ready to print. Thanks for watching the video. If you have any questions or need support with your printing, please reach out to us at gerstein.3dprinting@utoronto.ca.